Hey, welcome back to Code the Unseen. In the last video, we understood about how the entire SQL course from beginner to advanced is going to work. And today I'm super excited to bring the part one in front of you all. Today we are going to learn about databases, tables, the data types, either it's integer, string, or other data types, how to handle those, and the basic conceptual understanding of the primary key, unique key, composite key, foreign key kind of thing. As we are diving deep into the world of data, let's start with understanding databases and data warehouse and what set them apart. Whether you are building a business intelligence system or just curious about how information is managed, you are in the right place. So first of all, let's talk about databases. What exactly a database is? So a database is essentially a collection of specific type of information that's designed for real-time operations. It's used to store, retrieve, and manage data for day-to-day transactional activity. And that's why it is called OLTP, which is also known as online transaction processing. OLTP is all about speed and accuracy. When handling day-to-day transactions, think about banking transactions, order processing, or inventory management. Databases like these are designed to make frequent, small scale updates and ensure that the data remain consistent and reliable. Now let's switch gear to data warehouse and understand what exactly a data warehouse is. Unlike databases, data warehouse is built specifically for analytical processing. It stores historical data aggregated from various sources, supporting decision making and business intelligence. This is also known as OLAP or online analytical processing. OLAP systems are designed to analyze large amount of data and run complex queries. They are perfect for things like sales trends, customer behavior analysis, and perform reporting over it. This data is typically read heavy rather than write heavy, since the goal is to analyze rather than update it on a real time basis. And there are few properties of a data warehouse. It should always be subject oriented, which means it should always focus on a specific well defined subject instead of focusing entire enterprise level information at the first place. Then it should easily be capable of combining data from different systems across the organization. And that's where the second property of a data warehouse comes in, which is about integrating it. Now, the third is non volatile, which means your data shouldn't be changing very frequently. There should be a very specific reason, and that reason should always be pretty much valid and signed off from business before making any sort of modification over it. And then comes a time variant, which generally differentiate data warehouse from database. It holds a lot of historical information to support analysis and to facilitate decision making. Now to summarize difference between database or OLTP and data warehouse or OLAP. OLTP focuses on real-time transactional data which is quick and requires frequent updates. On the contrary, OLAP focuses on analyzing historical aggregated data which is complex and read heavy. Now let's talk about tables. In any database, a table is collection of rows and columns that stores data. Each table represents a specific entity like customer, order, or product, and columns define the attribute or field of that entity. Row are generally records, whereas columns are attributes. Let's get into data types. Every column in a table must have a data type, which defines what kind of data it can hold. For example, integer. For whole numbers, integer data type is used. Here you can see in year, there is integer as a data type being utilized. So what exactly it hold is not the entire date, but just 2023 or 2024 as a year value. Then there is varchar, which is variable length string, which generally holds text or a string kind of a field specific information. Then there is date value, which will hold, for example, let's say 10th of October 2024. And then there are two different ways to store date. In some cases, if you want to store date with time as well, there is a timestamp data type which is generally being used, and there are different nomenclature across different data warehouses. Within timestamp, if you want to look for, let's say, at 10th October 2024, around 11:15 p.m., something occurred. So you can store that sort of information within timestamp variable. Now comes float. Float generally store a data point with decimal. So the major difference between integer and float is integer will always hold a whole number, whereas float will have a specific decimal kind of a data point. Now Boolean, as mentioned, it will always show you either it's a true or a false variable. It generally, in any of the database, it's mentioned in 0 or 1 kind of number. Now let's understand CRUD operations. What exactly CRUD stands for is C stands for create, how to create a database or a table. Then comes R, which stands for read, how to read a specific information from a table or how to read an entire table. Then comes update, how to update a table within a specific database. And then comes delete, how to drop a database or delete a table within a database. We'll be doing hands-on these four operations and see how we can play around it. So let's do that. So let's say we have to create a database where we'll be storing employee information. So to create a database, we'll be utilizing a syntax called create database employee info. And either you can execute the statement under by clicking this or control enter. So we were able to successfully create an employee info database. Now here in schema, it's not visible yet. What you can do here is you can just click on refresh and you will be able to see this. And once you have created a database, let's use this particular database and create a specific table within this. So I'll be applying a syntax called use employee information. It's quite straightforward. What we have mentioned here is that we are going to use employee information to do further activity. Now let's create a employee table within it, wherein we'll be storing employees personal detail. We name employee details. Let's do that. And within employee details, we are going to store three information, which is ID, employee name, and gender. Also, SQL is not case sensitive. It's my personal choice to write all in, you can say, capital letter. What you can do is you can use capital, small, or proper normal case, whatever feels best to you. And employee ID is going to be, let's say, integer, and it's a primary key. So primary key is that it is going to be a unique element for each row item. It can't be a duplicate value. Then employee name is going to be a varchar value or a string value, right? And let's put a string length of 255. And I'll apply not null here because we don't want an employee name to be null within an employee details table. So not a single entry with null value will be passed within employee. Like if there is a employee name field empty within any of the row item, then it will get rejected or it will throw an error, right? And gender is again a varchar, right? Let's utilize the same character length just to reduce the time here. But in actual case, you should ideally utilize a lesser character length for gender because it's not going to be more than 5 or 6 string length. So yeah. Now we have employee details table available here, And within employee details, let's say you want to insert a specific value. Insert into, and then you wanted employee details table wherein you will be inserting this value, right? So within employee details table, there are employee ID, employee name, and then gender. And in values, so we'll be feeding in more than one values. So let's use employee ID 1 as June, and let's say June don't want to disclose her gender. Now in second, we have employee name Alice, and he is okay to disclose his gender as male. And in third, we have let's take example of Bob, and he is also okay to disclose his gender. Now make sure that you apply this colon at the end of each statement you have completed. So like in many other programming language, we generally use colon as the end or a full stop for that particular command. Now let's execute this. We were able to create a table called employee details, you can see here, and then we were also able to insert values within employee details. Now let's read that value. So we will learn about all complexer way or to apply a logic within a table, but for the sake of time and just to summarize the information for you, I'll be giving a quick select all statement. Here star stands for all from employee details, and now execute it. So here you see we have employee name and gender. Within employee name we have employee ID as we mentioned, and then there is June who. Now let's say if you want to uh, update this particular table, or there is a situation where in June comes to HR and she's okay to disclose her gender now, and she asked to put her gender as female. Now let's say we update a particular employee details table. So you'll be writing apply update employee details, set gender equals to female. But how SQL will understand that where exactly June is, or what is we'll be utilizing her ID within a clause to make SQL understand that within row with ID 1 you have to update a column named gender or the value gender. So seems like it worked perfectly. Now let's execute this statement again, the employee details one. Here it is. Now we in the crude operation we have understood how to create, read, and update a specific table or a database, right? Now let's understand how we can drop a specific table or delete a specific table, right? So we'll here we'll not be going into the delete or truncate statements. What we'll be doing here is we'll be for the time being we'll be dropping this particular employee details table for the time. And let's say if you want to drop a table called employee details, you can do that by utilizing this particular syntax. And if in case, apologies, I missed this. And now you can see it was able to drop an employee details table. But let's say if you also want to drop this particular database, then what you need to do here is just to replace table with database. Here it is. Sorry, the database name was employee info, right? So here it is. Now we were able to delete a employee info database, and you will not find that particular schema over here. Now let's understand about keys and its type. Keys are used to identify records which are unique in a table and also to establish a relationship between tables. There are different type of keys in SQL. So we will first start with understanding primary key. So here you can see a table at the bottom which include users and posts. These are the two different table within a database. So in users table, ID is a primary key which will be a unique identifier for each record. Okay, it can't be a null value, and you can consider the table can only have one primary key. Now coming down to foreign key. A foreign key is a column which act as a primary key in one table and a joining key or a foreign key for the another one. Here you can understand this by users ID. So ID of users table is available as a user ID in post table, right? So user ID in post table is a foreign key. Now coming down to unique key. A unique key ensures that all the values in a column are unique at record level. So you can consider that there are n number of records and combination of those three record or column will be exactly equal or unique. Sorry. And then unique keys can also include null values, and it is generally used to prevent duplicate values in the column or a set of a column. And then there is a composite key. Composite key can act as a primary key. It will never hold a null column within it, right? And it can be a combination of one or two columns. So let's say if there is a table wherein you can't create or you can can't you can not maybe create a primary key out of a single attribute, then in that case you generally merge more than one columns to bring that unique or to create that unique key, and that is known as composite key. Now we'll understand about how to read ER diagrams, which are entity relation diagram, and this will help you understand the relational databases structure. So what is ERD? ERDs are also known as entity relationship diagrams. So the term relationship here signifies that it shows the relation between tables within a database, or you can say that it always represents the structure of a database. As you are working on a relational database management system, also known as RDBMS, so how this works, let's jump into movies database and see that. So within movies database, you'll see there are five different table. One is named movie, second is rating, third is genre, fourth is director mapping, and the fifth is name, right? So now within this, all the tables are interconnected with each other. Let's pick movie ID, right? So you can see the green boxes, and when rating, genre, and director mapping, you can join this based on ID of a movie table. And let's say if you have a problem to solve wherein you have to answer that the title of movie which were published in a specific year, let's say 2023, you have to tell them the average rating, the name of the director, the date of birth of the director, and the genre of a movie. What you will do here, you'll be joining all these tables based on the IDs which are highlighted. And to join or to extract director name, the yellow boxes you can follow, right? You can see that name ID is linked with ID of a name table. So now in the next video, we'll understand how you can write a SQL query joining these tables and extract the information which is being asked. So thank you guys for everything, and let's meet in the next part. Super excited to have you all, and keep coding. Thank you.